In this video, we're going to talk about the work required to pump a liquid. So we are dealing with a vertical, right, circular, cylindrical tank with a height of 30 feet and a diameter of 20 feet. It is full of kerosene with a weight density of 51.2 pounds per foot cubed. How much work does it take to pump the kerosene to the level of the top of the tank? So let's think about what we're dealing with here. We have a right circular cylindrical tank. So right circular cylinder. We know that it has a radius of 10, since the diameter was 20, and a height of 30. So let's think about this. We have a typical slab. Remember, when we think about work for pumping a liquid, we think about them as all of these different horizontal slabs in here. So the typical slab between the planes, typical slab between our planes at y plus some delta y. That is going to have a volume. And volume, delta V, equals pi r squared times that thickness. So delta V is pi times my radius, 10 squared, times my thickness, delta y, because remember, delta is the change in that space. And obviously, we are approaching very, very, very thin, non-existent delta y's. So delta V equals 100 pi delta y feet cubed. So this is going to be my volume equation. And what we know is that the force required to lift that slab is equal to the weight times the volume. We've got the weight times the volume. So the force is that weight density, 51.2, times delta V, or 51.2 pounds per foot cubed times 100 pi delta y. And that's in pounds. And, again, think about your units. For my weight density, I had pounds per foot cubed times my volume, foot cubed. That's how I know I have this pounds here. All right, so we also need to think about the distance through which the force must act. So the distance through which the force must act, well, that is going to be some 30 feet minus y. So 30 minus y feet. Therefore, my work, W, is approximately the sum from 0 to 30 of all of those little slabs. Which is the sum from 0 to 30 of 5,120 pi times 30 minus y delta y. And that will be foot-pounds. And so you're saying, Ms. Stein, where'd that come from? Where'd the 5,120? That just came from multiplying these. I've got my pi, I've got my delta y, and my 30 minus y feet. So illustrating this as a Riemann sum, really this is just going to be the integral. So W is that integral from 0 to 30, because that's my vertical distance, of 5/120 pi 30 minus y dy. And so that differential came from that delta y value. At this point, in order to determine the work, we just need to integrate this. So the 5,120 pi, that's a constant. That will come in front of my integral, 5120 pi. Integral from 0 to 30 of 30 minus y dy. And integrating 30 minus y, I end up with 30y minus y squared over 2, evaluating from 30 to 0, or 0 to 30, however you want to think about it. I know that if I plug 0 into either of these, they're going to 0 out. So I end up with 5/120 pi 30 times 30 minus 30 squared over 2, which in the square brackets there, we end up with 450. And multiplying that out, that's going to give us 7,238,229.474, and that would be foot-pounds. So I ran out of space down here at the bottom of my screen, but that would be the quantity of work required to pump the kerosene to the top of the tank. As always, feel free to email me if you have any questions.